Welcome to Education for Nepal. This is our third lesson of this year. Okay. Yeah, we're gonna be here's our YouTube channel and stuff. And today we're teaching about chemistry, history, and math. All right, so for chemistry, we're gonna be talking about intermolecular bonding. So we'll start off with intermolecular forces. They're basically forces, they're just interactions between molecules. And they're different from intramolecular forces, which hold a single molecule together, like covalent bonds, ionic bonds. And there are three major types of intermolecular forces, which are London dispersion forces, dipole-dipole interactions, and hydrogen bonding. And you can see it in the bottom corner. The intermolecular attraction is between the chlorine in one molecule of HCl to the hydrogen in an entirely different atom, while intramolecular attraction is just between the hydrogen and chlorine of the same molecule. Okay, so for our first intermolecular force, we have London dispersion forces. They're a temporary attractive force, which happens when the electrons in two adjacent molecules occupy positions that make the molecules temporary dipoles. There's a weakest type of intermolecular force. They're also present in all molecules, and larger and heavier molecules exhibit stronger LDFs than smaller ones. And you can see it in the bottom right corner. Basically, you start off with like a regular atom, which has like the nucleus in the center, which is positively charged because of all the protons, surrounded by a bunch of negatively charged electrons. And over time, the electrons randomly change spots until the more electrons are in one area than another, which means they'll be attracted to the positively charged nucleus of another molecule. Okay, for our next intermolecular force, there are dipole-dipoles. They're just interactions that occur between polar molecules, and they're attractive forces between the negative end of one polar molecule and the positive end of another polar molecule. They're stronger than London dispersion forces, but weaker than hydrogen bonding. And all intermolecular forces and I think that's probably in the wrong spot, but probably I should have mentioned earlier that all intermolecular forces are weaker than intramolecular forces. And in the bottom right corner, you can see an example of dipole-dipole. Hydrogen chloride is a polar molecule, and the hydrogen part of it is positively charged, while the chlorine is negatively charged. So there would be attraction between the negatively charged chlorine and the positively charged hydrogen between the molecules. And for our final intermolecular force, they're hydrogen bonds. They're a special type of dipole-dipole interaction between molecules. They result from a hydrogen atom being covalently bonded to a very electronegative atom, such as nitrogen, oxygen, or fluorine. And they're much stronger than LDFs and dipole-dipole forces, usually. And you can kind of just see them. It's just the hydrogen bonded to and the oxygen of another water molecule. And I think that's it for chemistry. And so for history.
All right, today we're doing Spanish-American War. So it begun in the 1898s, but it started because of the Cuban War for Independence from Spain, which started in 1895. Spain sent Cubans to reconcentration areas. This is the first time that this type of thing was used in history. The conditions were horrible as usual, and About 400,000 died inside. So then US newspapers caught wind of this, so they published sensationalist newspapers where they sacrifice facts for, okay, it's not finished, but they sacrifice facts for more popularity to make it to blow things up. And this raised sympathy from the American public for the Cubans and gained support in Congress. The concessions were too little too late, and riots in Havana, the capital of Cuba, led to the USS Maine being sent to protect US citizens and property that was in Cuba. So then the Maine was blown up at its dock, and it was blamed on Spain. Uh, Now in the present day, we know that wasn't actually Spain. It was probably just some malfunction. But this prompted more yellow journalism, which is basically the sensationalist newspapers that in the previous slide, they're basically the same thing. And this led to US intervention, and they sent an ultimatum to Spain, telling it to stop its camps and give Cuba independence, which Spain refused. So then they declared war on us, and then the US declared war on Spain. All right, so there's not much to compare here. The war was not expected at all, so both sides were unprepared. But overall, the United States was just much stronger at that point. We had a much better navy. We had more ships, destroyers. We were more well trained, and the training itself made the soldiers confident and aggressive. Meanwhile, Spain kind of knew they were going to lose, so their morale was generally low. All right, so fighting the war, it's pretty obvious, but it was really one-sided. There weren't many battles that happened because all of this ended within the same year. So one of the battles was the Battle of Manila in the Philippines. Americans destroyed the anchored Spanish ships with naval gunfire without much resistance. And then at another one, the Americans blockaded the Santiago harbor where the Spanish had ships and the ships were being commanded by Admiral Pascal Cervera. And after they landed, land troops went on the other side, basically pincering them, forcing them to fight the troops that had landed or try and reclaim the ships, which none of them worked. So they eventually surrendered. All right. So the end of the war, the Treaty of Paris was signed in December 1898. So, and then in the Treaty of Paris, Spain relinquished Cuba, Philippines, Guam, and Puerto Rico. You can see in the map in the bottom right. Um, After the war, this was the United States, all the United States territory. So you can see the big piece to the right, Alaska, and then the little purple parts at the bottom left, and the little purple parts beneath the United States. The US did not believe that the Filipino people could rule themselves, so McKinley decided that the best course of action for both us and the Philippines was to take possession of all the 7,000 islands and around 7 million people living there, which led to the Philippine-American War. So then after this, the US was basically a world power because we had possessions in the Caribbean as well as in the Pacific Ocean, allowing us to take better advantage of like trading with China and India. Spain also kind of benefited because now they could focus on rebuilding itself instead of overseas because we basically took everything they had, sparking a renaissance in Spanish life, like intellectually and artistically. Right, so just some three quick questions. Does anyone know what yellow or sensationalist journalism is? It was in two slides, I think I mentioned it, the beginning ones. All right, I'll just say the answer, but it's basically newspapers
Please
with,
the question.
wait, can you repeat that?
What is yellow? Okay, I told the answer.
Okay, so yellow journalism is just journalism like reporting the news that have little well-researched information, so it's not really trustworthy. So if you go back to the second slide, um, the giant letters, like the title is "Destruction of the Warship Maine was the work of an enemy," when we didn't know that yet. So they just kind of assumed that in order to get people to buy the newspaper. So that's basically what yellow journalism is, like those flashy headlines. All right, and then the second question is which side, US or Spain, had the advantage in the war? It should become pretty obvious when you saw when in the slide comparing the two. I don't think I listed a single positive for the Spain.
The advantage US had the
Yes,
advantage in the war US had. They are more navy than Spain,
yes, that's
quality
correct.
military,
Yeah, that's correct,
and
Cecile.
confident and aggressive dictator.
Yes, that is correct. All right. All right. Number three. What are just list two of the territories that the U.S. gained from the war? We gained four in total. I don't think anyone remembers, but so we gained Cuba, Philippines, Guam, and Puerto Rico. So any of those two would have worked. All right.
Yeah, okay.
All right. Next section is math.
Okay, so today in math, we're going to be doing something called Boolean algebra. This is more of like an intersection between math, logic, and computer science. So Boolean algebra was invented in 1854 by George Boole. That's why it's called Boolean algebra. And there's three important laws. Probably seen these laws before in math. It's commutative, associative, and distributive laws. And there are seven total operators. Okay, you guys probably have not seen this unless if you already learned this before. Not, or, and, nor, and, so, or XNOR. Okay, so these are the Boolean laws. Most of you guys probably already know this. So the associative law just means um like parentheses doesn't matter if all the signs are the same, right? So in the example below, you can see that since everything is addition, it doesn't matter what parentheses and where you have parentheses because it's the same exact thing if you add A and B first or B and C first, because eventually you have to do all the same things. However, if you have multiplication and addition, then you have to follow the basic math rules or like PEMDAS. and you have to first do multiplication and then do addition, right? So next one, just commutative law, which just means if you flip A and B, it's the same exact thing. So in the example, you can see A plus B equals B plus A. Like most of these laws are really self-explanatory and kind of obvious. And the last one is the distributive law, which just says that anything outside of parentheses multiplied into things inside of parentheses, you have to multiply to everything in the parentheses. So in the example, you can see that it's A times parentheses B plus C. So you have to distribute A, so that becomes A times B plus A times C. But yeah, these are just the basic laws, and most of them you don't have to memorize them. Okay, so Boolean operations are kind of like math, but they're also a bit different. And so this part you might want to know. So the first thing you guys all need to know is that all Boolean operations have a truth table. I don't know who came up with the name truth table, but it is what it is. Basically, it's just a table that shows you all possible combinations of A and B, and then Y is the outcome, right? So if we look at the left, we'll first start with and. In computer science, if you ever want to use the and operation, you have to use two and symbols. And the and operation is basically like multiplication. Because if you look at the table, 0 times 0 equals 0, 0 times 1 equals 0, 1 times 0 equals 0. And only when you have two ones, then the outcome is 1. So we actually don't say 0 and 1. We usually say 0 is false and 1 is true. So basically, normally if we look at this truth table, we would say if A and B are both true, then Y would also be true. You see how that makes a lot more sense and why it's the word and, because A and B both have to be true in order for the outcome to be true. Now, if you look at the or truth table, now it's A or B could be true and the outcome is still true. That's why you only see the outcome being false when you have two zeros, because if A is false and B is false, then it's impossible for the outcome to be true. However, if either A or B is true, then the outcome is going to guaranteed be true. Okay, the next one is exclusive or. Exclusive or just means only one of them can be true. But obviously, at least one of them still has to be true. So you can see that there's only a small difference in that when both of them are true, the outcome is also false because this is exclusive. That's why it says X or. X stands for exclusive. And it just means that you can't have two truths, or else it's not exclusive anymore, and now everyone's essentially true. The final one is not. Not is self-explanatory. It just flips the value, so it either goes from true to false or false to true. Okay, and then here's the rest of the Boolean operations. At the left side, we have and, which is short for not and. So in the name, you can kind of tell that it's actually two operations, like the basic ones put together. It's the not operation plus the and operation, right? So normally, if you go back to the other slide, the and operation is only true when both A and B is true, right? So we would see that if A and B are true, then the output is true. However, not and is the exact opposite, because remember, not reverses the whole thing. So in not and or and, you can see that only the last row is false and all the other ones are true because it's the exact opposite of the and table. And the same thing is true for the nor, which is short for not or. You can see that only the first row is true, whereas all the other rows, the output is false. And that's the exact opposite of the previous or table, where all the all of them were true except for the first one, which was false. And the last one is just another two operations put together. This one's just the XOR plus not, so it's a bit confusing. But this is basically the exclusive not or. So if you look at the difference between um nor and X nor, it's just that when both A and B are true, the output is still true. So basically the last row is different if you compare the two truth tables. So this stuff might be a bit confusing at first, but as long as you get the basics down, it'll actually come to you really easily. Okay, thank you all for coming. And if you don't have any other questions, you can just fill out this feedback form and feel free to leave the meeting.